Welcome to AGI's Earth Day webinar to celebrate the kickoff of our 2025 Earth Science Week theme of Energy Resources for Our Future by looking at the science of net zero buildings. Today's speakers will talk about the importance of monitoring energy use and the careful consideration of the energy resources we choose, as well as how these choices impact the environment, energy-related career opportunities, and the economy. Now let's hear from Aidan Sharon, Associate Director of Global Earth Day.
Hello, everybody, and happy Earth Month. My name is Aidan Sharon, and I am the Associate Director of Global Earth Day at earthday.org. Today, we're coming together to celebrate our planet, reflect on the progress we've made, and take meaningful steps towards a more sustainable future. But the celebration just doesn't stop here. This is also the kickoff for Earth Science Week 2025. This year's Earth Science Week theme aligns perfectly with the Earth Day theme, Our Power, Our Planet, and reinforcing the crucial role of geoscience in addressing the environmental challenges we face. Our goal is to keep this conversation going throughout the year, inspiring action, education, innovation that lasts well beyond today. Earth Science Week is a time to recognize the value of geosciences in our everyday lives, from understanding climate change, developing new sustainable technologies. It's also an opportunity to explore, learn, and engage with the science that helps protect our planet. As part of our Earth Day celebration, we want to introduce a special webinar focused on net zero buildings, highlighting the American Geophysical Union headquarters in Washington, D.C. This building stands as a beacon of sustainability, demonstrating how cutting-edge design and innovative technologies can help us achieve net zero energy consumption. The AGU building is powered by renewable energy sources, incorporates advanced water recycling systems, and utilizes geothermal heating and cooling. These features make it a model for the future of sustainable architecture, but beyond its impressive energy efficiency, this building is also home to a small school, a unique learning space where students engage with science and sustainability firsthand, and one that I've had the privilege of teaching there. And I've seen the impact of that environment on those young learners. Imagine going to school in a building that itself is a lesson in sustainability, where students don't just read about the green technology or get taught about the green technology, but they experience it on an everyday basis. That's the power of integrating education with real-world solutions, and that's what we're excited to highlight in this webinar. We'll explore the building's incredible features, hear from experts about the importance of sustainable construction, and discuss how net zero buildings can become the norm rather than the exception. So, also on top of all that, we want to talk about renewable energy. We often focus on its environmental benefits, which is great. There's no direct emissions. We have a reduced reliance on fossil fuels and a more sustainable future. Renewable energy sources like solar, wind, and geothermal help mitigate climate change, improve air quality, and reduce our dependence on finite resources. Additionally, they help to create local job opportunities and promote energy security by diversifying our power supply. But it's also important to recognize that even renewable technologies require critical minerals and materials that come with their own environmental considerations. The production of solar panels, wind turbines, and batteries rely on resources such as lithium, cobalt, and rare earth elements, which have to be mined and processed. These processes can have environmental and ethical implications, which is why responsible sourcing and improved recycling technologies are key to ensuring a truly sustainable transition to clean energy. And as we expand our use of renewables in the world, and we're hoping to see a tripling of renewable energy generation by 2030, we have to also invest in research to make them more efficient and sustainable. Scientists, engineers, and policymakers are all playing a huge role in shaping a cleaner and more responsible energy future. Part of this Earth Science Week is we want to introduce career growth in sustainability. The renewable energy and sustainability sectors are experiencing unprecedented growth. It's great to see, creating job opportunities in a wide range of fields, from engineering and geosciences to environmental policy, education, and sustainable business practices. There are countless ways to contribute to this movement and the movement for a greener planet. Geoscientists are studying the Earth's resources to improve our ability to harness renewable energy, while engineers are designing more efficient solar panels and wind turbines, and even the less sexy sounding or less, great sounding heat pumps, which are doing a huge pull in making our buildings more energy efficient. Policymakers are shaping regulations that promote sustainability, and educators are inspiring the next generation to pursue careers in environmental science. Whether you're a student exploring future career paths or professional considering a transition to sustainability, now is the time to get involved. And these careers don't just benefit the planet, they're also driving economic growth. Clean energy jobs are among the fastest growing in the world, offering meaningful work that contributes to a healthier future for us all. Earth Day may just be one day, but Earth Science Week in October provides another opportunity to celebrate and engage with the geosciences and sustainability. By recognizing both, we can keep the momentum going all year long. Let's commit to learning, innovating, and taking action every single day to protect our planet. Each of us has a role to play, whether it's making sustainable choices in our daily lives or supporting policies that promote clean energy or even pursuing careers in environmental science. All of our actions add up, and together we can create a future where sustainability just isn't an aspiration, it's the foundation of how we all live. Thank you for being a part of this journey, and we look forward to celebrating with you throughout the year.
Net zero is a goal to have the amount of greenhouse gases released into and removed from the atmosphere to be equal. There are many natural processes that cycle carbon through the spheres of Earth. However, human activities are adding more carbon dioxide to the atmosphere than is being removed. The use of fossil fuels as a primary energy resource contributes to the net gain of carbon dioxide by the atmosphere. Innovations in technologies that allow humans to decrease emissions can help us work toward net zero, but the reality of how much excess carbon dioxide is already present in our atmosphere also requires the use of processes like carbon sequestration to remove carbon dioxide from the atmosphere. When we look at the use of energy in buildings, we can see that specific functions and equipment require significantly more energy than others. This data shows the average breakdown of energy use in office buildings and reveals that heating and the related processes of ventilation and cooling account for over 50% of an average office's energy use. And we see the same trend in most types of buildings. This data provides insight for those constructing new infrastructure or renovating existing buildings and can inform decisions to help reduce energy use and associated costs. One such building that has made these renovations is the headquarters of the American Geophysical Union in Washington, D.C. Renovations took place from 2017 to 2019 and resulted in the installation of features that meet the engineering principles of reduction, reclamation, absorption, and generation. We'll now hear from the Interim Director and CEO of the American Geophysical Union, Janice LaChance, about the planning that went into the renovations in the AGU headquarters, followed by a detailed look at specific aspects of the building that contribute to its net zero status.
The net zero renovation is very exciting and very extensive. There's a lot to it. And so I was wondering if you could talk first about how the renovations to make the building net zero came about in the first place, what the inspiration was for those renovations, and just a little bit about how that relationship started with all the different partners. That would be great to hear your reflections on such a great project.
Great. Thank you so much for that question. It was an interesting time, and it was a time of very important decision making for the AGU board. The building's life cycles were coming to an end. All of the different systems were starting to have to be renewed or renovated or reconsidered in some way or another. And the board realized that they had an opportunity here. They could have sold the building, moved into newer space. They could have rented newer space. They could have torn down the building and built something new. But they realized that this was a learning moment. And as scientists, they also realized that they could test a hypothesis, that they could be part of the deliberations and the study and the research around sustainable building practices. So they decided to renovate the building, and they decided to renovate it as a net zero energy building. But that sounds pretty easy, but it was a bold decision because it was a little bit more expensive than the alternatives. And frankly, no one had ever done it before on a tight urban footprint. Most net zero energy buildings have very large flat roofs that you can add an endless amount of solar panels to, or other technologies, wind. We couldn't quite manage any of those as a single solution to getting to net zero. So the board and the staff put an excellent team together of architects and engineers who were just immensely committed to the project. And they were able to put together a scenario where we could get to net zero. But it wasn't just, as I mentioned, one solution. It wasn't just solar. It wasn't just wind. It took some 25 strategies to come together and work through in the building to get us to net zero. So it's a tremendous success, and it really is an extraordinary example to the construction, building, design industry. People who care about climate come to our building to see how we did it. And even though they might not get to net zero, there's almost always a technology or a strategy that they can adopt to improve their own energy consumption in their own physical space.
Wonderful. That's great. And the planning process, so you talked a little bit about how things kicked off, what sort of precipitated doing this. Obviously, there was a lot of pieces of the puzzle. If you can share a little bit about the process, the sort of the planning process, the actual doing of this, and specifically about a challenge that might have come up within this process and how it was handled. That would be great to just share about, the idea of this collaboration, because I know there were so many different partners. If you could speak a little bit about that.
Yeah. The two main partners who we worked with were Hickok Cole Architects and Interface Engineering. And everyone worked as a partnership. There was no lead firm who gave out orders. Everyone worked together with our construction company, with the staff, to make sure that we were getting the very best thinking every single day of the project. The other thing we did that I think is a little not unusual, but maybe we leaned in a little bit more on this, was we wanted to bring in DC government and our neighbors. The building sits right on the edge of a historical neighborhood. It's a residential area. We wanted to be sure that the neighbors understood what we were doing, why we were doing it this way, why it was important to really set up this record of achievement in sustainable building practices. And we wanted DC government to understand what we were doing and see if they were willing to partner with us and help. We were very fortunate. It was a very, very strong team, and we had a lot of support from DC government. So a lot of communication during the renovation. The building had its own website. We had a mailing list. We communicated openly and frequently with our neighbors, with our partners, with everyone involved in the renovation, just to make sure that everyone was heard. There were a lot of challenges. Some of the technologies that we implemented had never been done before. It had only been done maybe once or twice. For example, we're drawing heat from the DC sewer system. That's pretty common in Europe, but had never been done in the United States. So there was a risk in bringing this equipment over from Europe and actually opening up one of DC's sewers lines that run parallel to the building on Florida Avenue. There was a huge risk. We didn't know what we would find. The sewer had been built in the 1890s. It was made out of brick. We didn't know what was going to happen, if the thing was going to collapse. And we did it the day before the Thanksgiving holiday in the United States. And so potentially all our wonderful neighbors who'd been so supportive of the project might not have had sewer service for the Thanksgiving holiday. Thankfully, there was a lot of really good planning. Again, this partnership with DC government who allowed us to do this, who gave us instructions on what we could do to mitigate the risks of such an exercise. And they liked it so much that they used the same technology, a different company, but the same technology for their new headquarters for the DC Water Department. So this is something that other people can replicate. And that's, to us, what's most exciting about it. We give tours to thousands of people every year who walk through to see what it's like, to see what we've done, to see, frankly, the beauty of it. It's a gorgeous building, very comfortable, and we think it has had a real impact on how people think about renovations, how they think about looking after the climate, looking after our planet when they're engaging in a construction project.
Excellent. There seems to be this intersection between the sort of oh wow and oh no. There were a lot of things that you touched on that are really cool, cutting edge technologies, and then the reality of making that happen. So I guess if you could talk a little bit about, and you did a bit, but the biggest benefits of the renovation, and as we sort of mark this Earth Day, what does that mean for the future of other folks who want to undertake net zero? But specifically, what are those benefits? What does the building give back?
Yeah, well, we're excited that we were able to prove it can be done. That was sort of the big first thing. And because AGU members are scientists, they were prepared to accept failure if it didn't work out. But it has, and it has continued to be a model and a learning opportunity for people from all walks of life and all professions, whether they're involved in construction or design or engineering, all the way to people who are just conscious about the environment and want to do what they can to help us on days like Earth Day and frankly every day of the year. It's that, I think, is its legacy. There's also the individual technologies that are just so interesting. I talked about the tapping into the source system, and there's so many stories about that I could tell, including the anxiety that I felt when we actually did it. But it worked. The other thing we did was we came up with a way to maximize the number of solar panels on the building. So it covers the roof that you can see behind me, and it goes down one side of the building, at least partially. So we maximized the amount of solar power that we can get into the building. We also found a way to keep the temperature consistent throughout the year. That comes with the help of the sewer system in DC government, so we're grateful for that. But there's also a way to maintain the temperature so that we're only adjusting up or down a few degrees every day so that people are comfortable. We also have direct current. Apparently, I did not know this before I managed the renovation. You lose a lot of power and lose a lot of electricity. You lose a lot of electricity and power and valuable electricity when you're switching from DC current to AC current. So, if you have a laptop computer or a tablet, you get this sort of cube thing with it. And that's what that does. It switches the current. So we decided, why would we have to switch? Let's just have everything connect to direct current. So we're using that. We also have a gorgeous green wall. If you've been in our building, it goes up the entire 5 floors and it's in our lower level as well. The company who constructed the green walls said they had never done one that has gone 6 floors before. So that's another thing where you think, well, green walls are really common. Yes, they are, but now we've shown they can go into an office building and help us maintain clean air, help us maintain the comfort of the people who are visiting us. Also, we have these great windows. If you ever come to our building, you'll see that the buildings adjust to the amount of sunlight that are coming into it. Again, helping to regulate and modulate the temperature so it never gets too hot and hopefully never gets too cold. That also helps with some of the reflection that you get on your computer screens. It has eliminated the need for shades or drapes, which has saved us money and cleaning expenses over the years. And they're just incredible windows made by Sage Glass, and we're just so happy to have them. But when we did this renovation, we went down to the studs. We replaced everything, but we didn't just replace, we reused. So all of our old windows, all of the old stonework in the building, and all of the sinks and toilets went into the terrazzo that we use for our floor and for the surface of the table in our boardroom. So we had a commitment to reuse. We didn't want to fill up the landfills. So even those sorts of sustainability practices are things that are usable for anyone in the community. Even if you're doing a renovation in your own home, you can use some of those practices that we put into play for our building. Earth Day is an extraordinarily special day. For years now, we've been celebrating the planet that we live on. And one of the ways that we can honor the planet and take care of the people who live on this very special planet is by thinking about how we build and construct the places where we live and work. The AGU building is one extraordinary example of how we can leverage multiple technologies to get to a net zero output of energy and actually give back. On the weekends, we give back to the city of Washington, D.C., to the district, because we're not using the building on the weekends. So all of the power generated by our solar panels get given back. And that combination of commitment to the planet, a willingness to give back, it really gives us a blueprint for how we can help our planet get through these very, very challenging times with our climate. It can help stop extreme weather. It can help stop natural disasters. It can help our scientists conduct their research in a way that results in some very, very practical steps that anyone can utilize. It's wonderful to be with you all today, and I want to welcome everybody to this very special celebration of Earth Day by taking a look at the AGU headquarters building. It's an honor to be able to speak with you and to show you this place. But what's most important is that we all understand, recognize, and value the symbolism and the importance of an Earth Day celebration. Thank you for joining us. I also want to thank AGI. They're important partners to us in the scientific community, and they've done such a wonderful job demonstrating the value of science, the importance of the work that we do to our planet and to climate change by hosting this very, very special program. So thanks to all my colleagues and friends at AGI for the opportunity to tell you about the AGU headquarters. I also want to raise a very, very special moment and effort in the AGU building renovation process. We were so committed to reusing the material from the old building in and incorporating it into our new look that we even saved the bricks that came off the facade of the building as we were removing windows and outside trim. And we had a crew of wonderful ladies, about 4 of them, who would sit in the lobby and clean off the bricks so that we could reuse them again. It was an extraordinary demonstration of the commitment that AGU and its board and its members had to making sure we weren't just filling up landfills and that we were actually committed to reusing, recycling, upcycling, and getting the most out of the materials that already existed in the building.
We're here at the AGU headquarters. My name is Matthew Boyd, the Director of Operations here at AGU, and I would like to talk to you about the tours that we provide here at the facility by starting off with the signage that we have throughout our facility, showing our different energy as unique equipment throughout the facility and other features in the building. But the energy really starts outside, so let's go outside. All right, so the energy starts here at AGU, coming from this manhole from the sewer. We make a tie into the sewer. They take combined sewer water to help aid heat and coolness in this facility. Hi, we're here in the garage at AGU headquarters, and we're going to show you our geothermal source for the facility, which is provided to us by Huber Technologies. This is the row wind and third wind system that we are able to take combined sewer water from our neighbors upstream of this building and bring it to our facility and help heat and cool us.
Hi, I'm Nate Madding with Huber Technology. I'm the Director of Green Building Solutions and really excited to talk about the American Geophysical Union building and how we're using wastewater energy recovery to heat and cool the building. So in the image you're seeing, the diagram, we're looking at the Huber ThermWind solution. And what we're doing is we're tying into the main sewer below Florida Avenue. We are using a Huber ROK4 vertical screen, and we are removing the solids from the sewer and bypassing them in from the wet well back into the sewer. And we're sending all of that screened sewage into our Huber row wind heat exchanger that Matt is going to talk about in a moment. So this is a way that we can utilize the sewer almost like a geo loop of renewable energy that's always flowing under Florida Avenue to provide energy exchange for heating and cooling of the AGU building. So Matt, if you want to talk about how we integrated that with the full building.
Our design engineers saw that we can actually tap into the sewer and utilize that as a geothermal source once they got the data. And the design of the system was for Huber Technologies to have a wet well in between our building and the sewer, so that can be our connection point to the sewer. And from this photo, you can see the wet well right here in our plaza between our building and the sewer system. And we actually tapped into the sewer right here in this photo from the 1890s. We had to reinforce the sewer 35 feet in length to ensure the integrity of the sewer before we actually drilled into the sewer and made that connection. The next photo shows where the gentlemen were actually starting up our equipment for the very first time, allowing us to take that great geothermal source energy from the sewer and utilize it in our facility to heat and cool our facility. And I'll go back over to you, Nate, to tell how that actually works.
Thanks, Matt. So we'll show a quick animation of the heat exchanger and kind of describe how that works. So the heat exchanger itself is a shell and tube style heat exchanger. And that means the wastewater is on the outside of this tank. And on the inside are pipe bundles with a secondary loop that then goes in the building to Matt's heat pumps to provide heating and cooling. So if we look at the animation, you have the wastewater is being pumped from that wet well into this tank, and here it's flowing across this tube bundle. So you have the wastewater on the outside. It always has a very nice consistent temperature, and it's going to flow through and then leave the heat exchanger, goes right back into the sewer, and keeps on going down in the DC water system. On the inside, you have this secondary piping bundle. So that secondary loop has either hot or cold water, depending on what the building needs, and it's going to be doing that energy transfer. So the way that we access this wastewater is the wastewater is really dirty, and so we have an automated cleaning system. So there's a integrated cleaning carriage that's going to go and, I always say, squeegee each pipe. So it goes from one end to the other. It makes sure that all of the biofouling is removed from the pipe bundles, and that biofouling is then going to kind of settle down into the bottom of the tank, where it's removed by an auger and sent back out to the sewer. Yeah, and so it's really nice to use the sewer in the street because it's a consistent source of energy. It's always flowing and it always has a very consistent temperature. And so if you think about when you're going through your daily life, you're showering, you're running your dishwasher, maybe when you get home you're putting in a load of laundry, and so you have all of that really nice water that's being really just wasted. It's flowing through the system and it's going out to, in this case, the DC water system. And so there's a ton of thermal energy that's really just flowing through that system. It's not being used. And what we typically see in buildings, they account for nearly 50 to 60% of all the energy use if you think about an urban core. So typically when people think about reducing energy consumption, you're thinking about electricity, but the main user is heating and cooling buildings. And so that's why it's such a big component of the AGU kind of story. So they have all those different components, right, Matt? And you've integrated everything together to decarbonize that building, and that main part is decarbonizing with heating and cooling.
Absolutely. So we, like you're right, we take our neighbor contributions that's upstream from our building. We have a hotel, we have apartment complexes right up from our building. That energy comes into our facility, makes an energy exchange with our building base source water, which we actually use is rainwater. It's the source water that works in conjunction with the Huber system. And we utilize that rainwater throughout our facility. It goes to a water heat pump or a plankton frame heat exchanger and runs through our building through radiant panels that cause latent cooling down to the occupants below to heat and cool people in the facility. So it's a healthier system by far from other buildings that I operated in the past, which was force-blown air. I don't have people with goosebumps in the summertime, the radiation from the cooling panels. My complaints dropped tremendously from that aspect with that form of HVAC for the occupants in the building.
Here on the rooftop of our facility is our DOAS system, our dedicated outside air unit that provides 100% ventilation air to the facility. And also out here on the roof is our rock quarry roof. This is where the rainwater goes through our drainage pipe that goes down to the cistern that we capture our rainwater. And the DOAS system actually has the condensation drain pipe over to the roof drain pipe, that we can capture that water in the summertime as well and reuse that to water the plants in the facility and go throughout the facility to flush our toilets as well. We have 719 solar panels that generate 256 kilowatt of power of this facility, and these panels are about 22% more efficient than your typical solar panels. So this is one that we actually have in case if we need to, if one of them go bad, we can put it on the roof.
Can you tell us a little bit more about how this green rooftop works?
Absolutely. So the green roof is designed when it rains here on the facility, all the water, rainwater falls within the footprint of the building and runs right through our green roof. It goes down to our cistern via the roof drains. And we have 11,300 gallon cistern in the basement that captures that rainwater. And when needed, we'll pump that water back up here to the roof, and it goes through a drip irrigation system that waters the green roof from there. Now, the combination of plants were chosen to be in a shade tolerant environment. So there's a fern based plant, there's plants that symbolize like strawberry leaves, and then like a lily plant leaf plant that survives really well in the shaded environment. And it was the right combination of plants to survive in that environment. And it's pretty cool to see rainwater go through the plants and then be reused to water the plants again. I want to talk about this rendering drawing. What's unique about AGU's architecture is that the building was originally built in 1993 to be shaped like a ship for geophysicists to sail over Washington, D.C. The original design of the facility had everybody at the top tier of the building with a grand view of the street, and then it was punch windows, not really giving everybody the grand view. So the architects really opened up the building from top to bottom, giving everybody a grand view, but also adding in natural light into the facility. We have in this facility triple pane windows. Our old version of the building had double pane windows, and what I've noticed from having double pane windows to now triple pane windows, it dampens down a lot of sound from the street, urban street outside of our facility. So what's unique about these windows, they actually tint anywhere from 60% visible light through to 1% visible light through. So this is the different tint levels right here. This is 100% clear. And also beyond just tinting to keep from glare control methodology here in the facility, it actually helps by tinting the windows, keeps the coolness in the facility in the summertime from an energy perspective. So we don't have to add an abundance of cooling in this facility to keep occupants at a comfortable level. I say one of the most surprising things I've learned from running a building day to day is actually seeing our geothermal source, which is the sewer, the temperatures coming in from the sewer when our neighbors in the morning time, when our building engineers are getting here between 5:30 and 7:30, that you'll see a dramatic change in temperature from the sewer, from people taking their showers, flushing their toilets, or cooking in their kitchen. We can see the temperature change right here. And then as it cascade on to like 8 o'clock during the day, the temperatures kind of normalize out as people go about their day.
We would like to sincerely thank Matt and the entire team at the headquarters of the American Geophysical Union for allowing us to take their tour. They offer free educational tours year-round, so please check out their website for more information. Our final presentation from Chris Gregg will discuss the NetZero America project conducted by the Andlinger Center for Energy and the Environment at Princeton University and data used to track progress toward net zero.
Hi, my name's Chris Gregg, and my talk today is about navigating the transition to a net zero economy. It's a great pleasure to be here with you as I talk about something that is a real passion for me, is how do we navigate this path. As background, I want to reflect on the fact that most countries, states, companies, cities have made very ambitious pledges to reduce their emissions to net zero by around the middle of the century. This is sometimes motivated by authentic care for the planet, but oftentimes it's motivated by coercion, whether it be from shareholders, NGOs, or their peers. To achieve these goals, however, we must build clean energy and industrial infrastructure at a truly astonishing speed and scale. And the models we rely on don't take into account the way we develop and build infrastructure, nor do they consider the trade-offs, whether it be with natural capital, other stakeholder interests, or financing. And this is the area that I want to explore today. I'm going to talk to you about the NetZero America study, which Princeton undertook in 2020 and 2021. This really brought the speed, scale, and the trade-offs to life. It attracted a lot of attention in the media, It led to us doing in the order of 300 briefings across the White House, Congress, state governments, but also the private sector, companies, financiers, international organizations. And then lastly, it inspired others to follow. So we've subsequently partnered with institutions in Australia, India, China, Brazil, where we're undertaking similar studies with our partners there. So what do we mean by net zero? Well, it's basically the state where we achieve that the amount of greenhouse gases being emitted into the atmosphere is being balanced by what we're removing from the atmosphere. And all pathways to get to net zero involve what I call 6 pillars of decarbonisation. The first is energy productivity. It's really doing more with less through a combination of efficiency and electrification. The second one is clean electricity. We need to build more solar, wind, transmission, batteries, but also firm generation options, things like nuclear, geothermal, carbon capture and storage with natural gas. These are generation sources which are always available on demand and are not dependent on the weather like wind and solar. We need to deploy bioenergy and other zero carbon fuels and feedstocks for chemical industry. And we need to capture CO2 from emissions point sources, and we need to either utilize that into long-lived products or to store it in deep geologic formations. And then the last 2 pillars are related often to the land sector. We need to reduce non-CO2 emissions, things like methane from cattle and nitrous oxide from fertilizer use. And then we need to enhance natural land sinks, develop our forest, prevent deforestation and so forth. So these are our 6 pillars, and they form pretty much the basis of every pathway to net zero, whichever country or organization you represent. Back to NetZero America, and it was really, I think, a unique approach around granularity, whether it be technological granularity, spatial granularity, temporal granularity. This was really where NetZero America came into its own. I'm going to show you some examples. This is a middle of the road scenario for, in this case, renewable energy, electricity. If you look at 2020 here, you can see in the map, the blue dots, they represent wind farms. And there are some orange dots there that represent solar farms in 2020. But as you can see, they're very difficult to see. And the grey lines are transmission lines. If we fast forward to 2050 in our scenario, you see this enormous build out of wind and solar, around 3,000 gigawatts of new wind and solar, roughly equal amounts of each. And we have to build 3 times the transmission infrastructure that we have today. Really quite an extraordinary change happening across the United States. But in the same scenario, we also have carbon capture and storage, or CCS. And in 2020, we have a small amount of CO2 being transported in pipelines and injected into the subsurface, mainly to enhance the production of oil. But in 2050, we would need to build out a whole enterprise of CCS, capturing CO2 at around 2,000 facilities, bioenergy plants, cement plants, natural gas power plants, all fitted with CCS, where we're going to capture 1 billion tonnes a year of CO2 and inject it into formations around 6,000 feet below surface. And to make that happen, we're going to need thousands of wells, and we're going to need around 100,000 miles of new large diameter CO2 pipelines. So these maps really show this astonishing scale, but also the speed at which we have to deliver of infrastructure by 2050 in a net zero scenario. We also looked at Australia. And so with our partners down in Australia, there is a unique challenge Australia, whilst it's a very vast continent, around the same land area as continental US, it is a relatively small economy. Our population is only 27 million, so it's 1/15 of the United States, and GDP similar. But at the time of this study, at least, we were the world's largest exporter of LNG and the largest exporter of coal. And so the challenge in Australia is to decarbonise the domestic economy, relatively small economy, by 2050, but also to transition our energy exports to clean energy exports, things like clean hydrogen or subsea transmission lines to take electricity into Asia. This becomes a much more interesting challenge. And if we forward to 2050, we see a very different picture to what we saw in the US. We see relatively modest build out of wind and solar and transmission to support the population centres near the coast, in the mostly in the southern part of the continent. But we see these vast hubs of solar and some wind to deliver clean, green hydrogen in the form of ammonia to our trading partners. And this ammonia will eventually phase in substitution for coal and LNG exports. As you can see, again, it's a big task. 3,000 gigawatts of solar, vast amounts of transmission, and of course, the clean hydrogen export infrastructure. So when we look at these maps, it can be a little overwhelming. And so we've tried to distill it down to really 4 critical challenges that we have to navigate. I call them speed limits, right? If we don't get them right, they represent speed limits. And it's this unique granularity, but also engaging with stakeholders who are impacted by the transition or engaged or influential in the transition that helps bring these to life. The first one that we talked about already is this unprecedented technology change and infrastructure build. We have to learn to build infrastructure much more rapidly, much more reliably than we have been of late. The second one, and it's critical to be able to deliver the infrastructure, is risk capital. To develop and build these new assets, we need cash, we need finance. And we need a lot more finance flowing into the clean energy and industrial sector than we have today. Then there's the sustaining social license challenge. With all this change going on at unprecedented scale and speed over multiple decades, we have to make sure our communities are on board for this transition. And the last one is the workforce mobilisation. It does require a large workforce, both professionals and trade labour, and we're going to have to mobilise people to do that. So let's talk about some of those challenges. We've talked about the infrastructure challenge, but now I want to talk about the financing challenge. To deliver net zero, we'll have to see somewhere between 3 and 6 times the flow of capital than we have been used to in the energy and industrial sectors. In the case of Australia, as an example, you can see here, in a business as usual world where we weren't committing to decarbonise the economy, we might have to mobilise around $1.5 trillion between now and the middle of the century. But in these low carbon scenarios where we're actually transitioning both our domestic economy and our export economy to a net zero economy, then we're talking about lifting that to somewhere around $8 trillion by mid-century. This is enormous amount of change, and it's going to require a rethink in how the finance sector, the government, and the industry is able to work together. Social license. This is really having communities endorse and accept and support this transition throughout the next few decades. And whilst the infrastructure challenge and the financing challenge are kind of national, global challenges, social license is often local. And so we have to get very granular to provide that local perspective. So looking at the renewable infrastructure, if we look at 2020, we've zoomed in here to St. Louis in Missouri, and you can see virtually no wind and solar in that region. Fast forward to 2050, and you see this tremendous build out. This is just 25 years, right? And we're building lots and lots of wind farms, the blue shaded area, and lots of solar farms, the red area, in and around St. Louis. And we're going to have to make sure that landowners, community groups, residents are accepting of this and supportive of this. But so far, we're not doing a good job of this. We've seen rising community opposition to many low carbon project types, solar, wind, CCS, but particularly linear infrastructure, things like electricity transmission lines and CO2 pipelines have been opposed in many states. And so this leads to growth in restrictions by local regulation. And we're also seeing evidence of declining trust across energy and industrial companies. So we're going to have to turn this around, right? If we're going to be able to commit to this transition in these kind of timeframes, we have to be a lot better at dealing with local communities. And last one I wanted to talk about is the workforce requirement. On this panel here, you can see the grey panel is the business as usual case for America, and the coloured panels are the net zero scenarios, different types of scenarios. And you can see, depending on the scenario, depending on whether it's heavily dependent on renewables or more dependent on CCS, we need more or less workers, but we need more across all of them. So whether it be 2 times or 4 times the workforce, this is a major challenge. And it's a major opportunity, of course, because everybody would like to see jobs created. There are some risks, however, because it's not homogeneous. What we find is there are states and counties where we see sharp declines in employment, but there are also counties where we see a huge influx required of workers. And so managing this in a way that supports communities, doesn't leave any behind, but also supports communities where we need a big transition of workforce into the community is going to be really critical. Last but not least, I want to end on what this means for the geoscience industry. Well, net zero globally means lots of geoscience professionals. For CCS, we need to be capturing and storing billions of tons of CO2 permanently, safely, and cost-effectively into deep geologic formations. This is the work of geoscience professionals. Hydrogen. We need to build a new hydrogen economy in the world that is going to be somewhere between 0.5 billion tons per year and 1 billion tons per year. This is an increase of 5 to 10 times what the hydrogen use today is. And to be able to balance supplies and demands, we're going to need to store that in subsurface caverns that have been engineered by geoscience professionals. If we're going to build 20,000 gigawatts of wind, solar, batteries, and nuclear across the world, and it may well be more than that, we're going to need geotechnical services to support the siting of this tremendous number of new facilities. And let's not forget critical minerals. The renewable energy transition is heavily reliant on critical minerals. We estimate that the energy transition will need a 10-fold expansion of lithium, cobalt, rare earths, but a 4-fold expansion also of things that we might take for granted, like copper and nickel. And last but not least, let's think about oil and gas. Most of these pathways do involve continued oil and gas production well beyond 2050. And so that industry will need to be supported as well. So overall, the future is very bright in an energy transition world for the geoscience sector. Well, thanks for listening. I think this transition to net zero economy is one of the greatest challenges, but also one of the greatest opportunities of this century. And I hope you'll be part of it. Thank you.
I'm Ed Robeck, Director of Education and Outreach at the American Geosciences Institute. This webinar demonstrates the vital role that earth science plays in developing sustainable communities. Choices we make about energy sources depend on our understanding of Earth systems and the use of Earth's materials. To help encourage awareness of the role of the geosciences and build geoscience awareness, for more than 25 years, AGI has facilitated Earth Science Week, which occurs the second full week of October each year, though many organizations celebrate Earth Science Week at other times, so it's really Earth Science Week all year long. I'm going to take just a couple of minutes to share some of the ways that organizations like schools, colleges, museums, communities and states, families, and individuals can all take part in Earth Science Week. Of course, one way to learn about Earth Science Week is to start with the Earth Science Week homepage, which is the hub for the resources made available as part of the program. Looking at the resources link, you'll find information about the media that were developed for past Earth Science Weeks, much of which is available through the Earth Science Week toolkits and online through the online toolkit. As AGI and our partners develop new materials for 2025, those will be added to the website. The webpage provides many ideas for getting involved, including contests across a variety of formats: photography, video, visual arts, and essays, allowing for different modes of expression regarding each year's Earth Science Week theme. The photography and video contests are open to participants from all over the world and of all ages. We've even had teachers who have made taking part in one of the contests a classroom project, encouraging their students to get involved and learn about the Earth sciences in those ways. This webpage also includes information about events and ideas and how to organize them, such as ways that you can connect your events to focus days that occur each year, like Minerals Day, Earth Observation Day, National Fossil Day, Geologic Map Day, and many others. Browsing through the events that have taken place in the past can provide inspiration for events that would be of interest to people in your organization and community. We've seen many kinds of events held during Earth Science Week each year, and we encourage organizations to host events in ways and at times of year that make sense for them and their missions. Organizing events around Earth Science Week can help to amplify the messaging about the importance of Earth science and of Earth science careers. Another way to share in the mission of Earth Science Week is by obtaining a state proclamation. There are currently 7 states with perpetual Earth Science Week proclamations to honor the role of Earth science in their state. And a variety of other states work to get annual proclamations, but we're always looking to expand that number. You can check with your state's executive office for information about how to obtain a state proclamation, keeping in mind that the average time for processing applications is 5 to 6 weeks. Lastly, signing up for our newsletter and following our social media channels are ways you can keep up to date with the Science Week resources that AGI and our partners are developing, as well as learn about future webinars related to this year's theme, Energy Resources for Our Future. And of course, the AGI Education and Outreach team is always available to share ideas and help in any way we can. We're always looking forward to hearing from you about the events you plan, that you hear about, and that you take part in. Thanks for attending this year's Earth Day webinar. We look forward to celebrating Earth Day and Earth Science Week with you all year long. Thank you.